Okay, so now let's try the sensitivity analysis just to test how the parameters or the main parameters that we have will affect the reactor volume. I'm gonna get it back to the 140 liters that we mentioned before, or that was the input that we have, and we can go for the flow sheeting options and go for the it's not the flow sheeting options, it is the model analysis tools, and go for the sensitivity and do one sensitivity analysis just to see how we can see the parameters affecting the reactor conversion. So I'm gonna define new variable. For instance, this is the manipulated variable, and in this case, I can test the effect of the reactor volume, for instance. So I'm gonna do this as number one. This is a block parameter. I think this is what we can do. Um, it's a block variable, and we have only one block, which is the CSTR. The variable is the volume. You can find here like a lot of things, and it might be kind of confusing. So you can search here. You can press on this and then mention volume. So you can have the volume of the specified phase, volume of the specified phase as fraction of the total reactor volume, reacted volume, whatever. So I need the specified reactor volume. And it's in volume units of liter. I'm gonna start with the 100, for instance. I have already 140, so I'm gonna start with 100, and we'll end with 1400, for instance, and the increment would be 50. I'm just picking anything. So now I have the parameter. You can add more parameters, but I'm gonna change this or use one for now. And for the variable that I wanna calculate is gonna be the I'm gonna call it the product flow rate, which is the molar flow rate of the product that I have, which is ethyl acetate. So I'm gonna make it as a stream in the category of a stream. Sometimes it's confusing. I usually would go for stream parameter or stream property or variable, but this is not where you should search. It should be in the mole flow of the product stream, and then the component is ethyl acetate. It is very common to get confused and search in many places. You will not find it because the way it's put, it's kind of confusing, at least for me. So I believe that it's not a big problem if you cannot find it and then search for another one of these options, and then try to find the flow rate that you want inside this list. Finally, in the tabulate, I'm gonna fill the variables. It's gonna put the product, and then I'm gonna do the run. So it did the simulation for all the points that I mentioned, and in each case it's calculating the flow rate of the ethyl acetate in the product. So the x-axis is going to be the volume and the product flow rate, and I'm gonna press OK. So this is how the flow rate or the product flow rate is changing with the volume of the reactor. So it's important to see or to kind of analyze the results that we have, because they are very valuable results. It mentions here that at the volume of 100, the flow rate was almost 120, and by increasing the volume 14 times, the conversion increased from 120 to 123.5. So I have very small increase in the conversion by a huge increase in the volume, and it means that I'm getting closer to the equilibrium conversion. Again, this is because I have a reversible reaction, and it's very nice actually to see. And this is expected in case of a CSTR, because by increasing the volume of the CSTR, you still have the products inside the same place where you have the reactants. So it's not like the PFR, the reaction is going forward and the products are leaving. It's not this way. So this is what we are gonna get. We can change it and see the effect of temperature. So I can change this variable and add a new variable, and I'm gonna call it or use this as temperature, you can deactivate this. So this is not gonna be an active parameter, and you see this is not satisfied now. You have to define something instead of it. So for the parameter number 2, I'm gonna make it as the block variable as well, and this block is the CSTR, and I'm gonna use the temperature just to make sure that this is the temperature that I want. It is saying the specified reactor temperature, so I was working at 75, so I'm gonna work from 40 to, let's say, 95 with the increment of 5. And I can run the simulation now and see now the results are available, so I can see the sensitivity analysis results, and this is how the flow rate is changing, and this is great. Let's take a look at it. It's kind of mentioning that the reaction is going kind of increasing as the temperature increases, and then it decreases after 80. And this is something that we can kind of expect because there is a reversible reaction. We can repeat it with a smaller increment just to see the effect more easily. So I have this increment of 5. I'll make it increment of 1, for instance, and then run the simulation, and let's see the results curve. So it's kind of increasing, and then gradually decreasing. This could be because of more than one thing, either because of the start of evaporation of one of the reactants after more than 80 degrees, like ethanol, and this will make the forward reaction slower or reduces the forward reaction, or because the backward reaction is increasing, the rate of backward reaction increases as the temperature increases. So it could be because one of them. I mean, we can go at this temperature and then study how the phases are changing inside the reactor. But at the end of the day, this is something interesting that we can study. One more thing that we can do, which is something that I would like to mention because it's gonna be very useful, and it can be life-saving, or I mean time-saving in case of someone who wants to do this, is when you are working with this reaction and want to test if the reaction was just forward reaction, you don't have a reversible reaction, and you can do many things actually to stop the backward reaction, but the thing that I believe is the easiest thing is to go for the backward reaction and put the K instead of this number, to put it as 0. And by doing this, you're saying that the backward reaction is 0, because anything multiplied by 0 is going to be 0. So I'm going to run the file and we'll see the sensitivity analysis results. You see the numbers are now more than they were before. It's 150 something, which is totally higher than the values that we saw before. It was 120 before, so I have like 30 moles. And you'd see this it's getting more and more. It's kind of linearly increasing, and I believe if we increase it more, it will reach the end of the reaction. So this is going to be something around 160. I don't remember what was the flow rate of the ethyl acetate or the ethanol in the feed. Let me check that. So we have here for the mole flow, it was 186. So we can reach 186 in the product if we kept going forward. But again, this is gonna require a huge volume because of the dilution that happens due to the presence of the reactants and the product in the same place. So anyways, so this is something that I felt it's nice to do and to see how the parameters can affect the performance of the reactor. So I hope it helps, and I'll see you in the next video, inshallah. Goodbye.